Today we're going to talk about triangles and special quadrilaterals. So most of this will probably be a review for you, but I'm going to highlight a few things for you. So first of all, we're going to talk about triangles. So triangles can be classified both by angles and by sides. So let's first focus on classifying by angles. Okay, so the first side is an obtuse triangle. It's a triangle of exactly one obtuse angle. Okay, and we say exactly because think about it, if I had a triangle, one obtuse angle there, and then I'd have another obtuse angle here, right? Those are my obtuse angles. These two ends here would never reach, so it couldn't form a triangle. I would need a fourth side. So that's why we can only have exactly one obtuse angle. An acute triangle has all three are acute angles. And a right triangle, again, has exactly one right angle, just like the obtuse. If I had two right angles, it would look like this, right? And the ends would never come together to make a triangle. So that's classifying by angles. Classified by its sides, okay, we have a scalene triangle here, so it's a triangle with no sides that are congruent. An isosceles has at least two congruent sides, and that's pretty important. Because a lot of times in middle school, especially, they talk about isosceles triangles having two congruent sides, but they have to have at least. And I'll talk about why that's important in 1 second. The last one then is the equilateral triangle where all three sides are congruent. So because of the definition of isosceles saying at least, an equilateral triangle is an isosceles triangle. But an equilateral triangle has that extra third side. But it can be classified as isosceles because it has at least two congruent sides. It actually has three. Okay, so this is one of those, like, is a square a rectangle or a rectangle a square? Okay, so an equilateral is an isosceles all the time because it always has at least two congruent sides. But an isosceles triangle isn't always, so sometimes it's an equilateral, sometimes it's not. It's an equilateral if it also has that third congruent side. But if it only has the two congruent sides, then it's just isosceles. All right, on this page here, I'm asking you to classify each shape of each triangle here by its angles and by its sides. Okay, so I can't have anything off to the side of my board, so I just made a new box up top here with right, acute, and obtuse. We have scalene, isosceles, and equilateral. All right, so I'm just going to go through and talk about angles first. Let's just focus on angles. So first of all, my first triangle up here has 60, 60, and 60. So all of those are acute, so this is an acute triangle. Right? So I know it's going to be acute. Then I have three congruent sides, so it has to be equilateral. So you can say it's an acute equilateral, you can say it's equilateral acute triangle. The order doesn't really matter. All right, the next one to the right there, we do have an obtuse angle, so it has to be an obtuse triangle. We do not have any sides marked as congruent, so we have to assume that they are not, so therefore it has to be scalene. The next one to the right, we have a right angle, so it has to be a right triangle. Again, we don't have any sides marked as being congruent, so it has to be scalene. Right? Same is true of the next one. We have a right angle, but we don't have any congruent sides there, so again, it's going to be scalene. Okay, the one in the middle. The one in the middle, we have all acute angles, so that's going to be an acute triangle. But this time I do have two segments with tick marks, so that has to be isosceles. My right angle marking got off there a little bit, so this is my right angle right here. So it is a right triangle, and this time we have two sides that are congruent, which makes it isosceles. Two more. So all the angles in the next one are all acute, so it has to be an acute triangle. And then none of the sides are marked as being congruent, so we have to say that it's scalene. The last one, looking at my angles, we do have an obtuse angle of 120, so it's obtuse. And then we do have two sides marked as being congruent, so it's isosceles. Right, so that's just quick practice of classifying your triangles. Now I want to talk about quadrilaterals. So we know quadrilaterals have 4 sides, just by the name, by the definition. All right, so we're going to look at some very specific shapes here, and we're going to study the properties of them further down the road. So today we're just really defining what the shapes are. So the first one here is a kite. All right, so a kite is a quadrilateral with 2 distinct pairs of consecutive congruent sides. Okay, that's a lot of information there. So 2 distinct pairs, meaning the pairs can't be the same length. Okay, consecutive congruent sides means that the congruent sides have to be in a row. So it literally looks like a kite. You know, like let's go fly a kite. Okay, it looks like a kite. So it has no parallel lines. A trapezoid is a quadrilateral with exactly 1 set of parallel sides. Okay, so this is a trapezoid, and I put this one up here because it's not your typical trapezoid that you would see. A lot of times people draw trapezoids that look like this, where these 2 lines are parallel. Well, that is a kind of trapezoid. A lot of times what they're trying to do is draw an isosceles trapezoid. Okay, a lot of times they're trying to draw an isosceles trapezoid. Those are like the pretty ones, okay? Where what's happening actually is the legs, which means the non-parallel sides, are congruent. Okay, so it's still a trapezoid because it has exactly 1 set of parallel lines, but it also has the legs that are congruent here. All right, now we're going to talk about parallelograms. All right, so a parallelogram, by definition, is a quadrilateral with 2 sets of parallel lines. Okay, this is the definition of a parallelogram. Now, where people get in trouble is you probably know a lot of properties of parallelograms. Like you know the opposite sides are congruent, but that's not what makes a parallelogram a parallelogram. So what makes a parallelogram is that they have 2 sets of parallel sides. Okay, these next 3 then are special kinds of parallelograms. Okay, so the next one is a rhombus. So rhombus is a parallelogram, meaning that we have our 2 sets of parallel sides, but it also has 4 congruent sides. Okay, so you're going to notice I have all my parallelogram markings because it is a parallelogram, but it also has 4 congruent sides. A rectangle is still a parallelogram. Again, if you look, we have the parallel markings. But what makes this so special is that it has 4 congruent angles. Okay, some people say 4 congruent angles, some people say 4 right angles. Nonetheless, they are all 4 the same. Finally, if we put a rhombus and a rectangle together, we get a square. Okay, so a parallelogram is a square with 4 congruent sides and 4 congruent angles. Again, I have all of that marked on here. All right, the parallel sides, the congruent, and the congruent angles. All right, so what I'm going to try to do for you is kind of put this all together. Because I know those shapes are probably not new to you. So we have here what's called the quadrilateral family tree. I'm going to try to zoom in on this a little bit here. All right, so the quadrilateral family tree here, it starts up top with all quadrilaterals. Okay, so we have all quadrilaterals up here, anything with 4 sides. Sometimes a quadrilateral is just a quadrilateral. But we can also break this up into a couple of categories here. Okay, first we had the kite. If you remember, the kite had 2 sets of distinct consecutive congruent sides. Okay, there are no parallel lines there. Then we had the trapezoids. We know the trapezoid has exactly 1 pair of parallel sides. And then we went over to we went over to parallelograms. We have 2 sets of parallel sides. So we went from no parallel sides to 1 set of parallel lines. And then we have 2 sets of parallel lines. Right? Then when we looked at those parallelograms, we talked about how we had our 2 sets of parallel sides. That rhombus took that parallelogram and made all the sides congruent. The rectangle made all the angles congruent. Okay, then we combined, we took all the properties of the rhombus and all the properties of the rectangle, we put it all together and we got our 4 congruent sides, our 4 congruent angles, and 2 sets of parallel lines. All right, so this is how they're interrelated. Now, a lot of times people like to do always, sometimes, never with these problems. Okay, so I put a little guide here. We can always work our way up the family tree. Okay, meaning we can start as a square and work our way up. Okay, a square is always going to be a quadrilateral. We can always be less specific. Okay, just like if I say I'm a girl, I could be less specific and say I'm a human and still be correct. Okay, or you can point to someone and say that's a boy or that's a girl. You may be right or wrong, but you could always be less specific and call them a human being. All right, so you can always be less specific. So that's what the up arrow here is for. Sometimes you can be more specific. So sometimes you can go down the family tree. Sometimes a trapezoid is an isosceles trapezoid. Sometimes it's not. Sometimes it doesn't have the extra property of the extra congruent sides. Sometimes a quadrilateral is a kite. Sometimes it's not. Okay. Then we have never. You can never jump left and right. So I can't have no parallel sides and one set of parallel sides all at the same time. So I can't jump branches off of my quadrilaterals. So we can never ever move left to right. All right, so what we're going to do now, we have a little sorting activity here. We're going to look at, here we go. We're going to look at a few statements, and we're going to decide if it's always true, sometimes true, or never true. Okay, so you might have to look back at your family tree, okay, and I'll flip back and forth. That way you're kind of understanding what I'm talking about. All right, so I have the purple one, I think from the bottom first. Does a rectangle is a quadrilateral? Okay, so a rectangle is a quadrilateral. So a rectangle is here, and a quadrilateral is up here. Okay, so can I go up the family tree? So I can always be less specific. So a rectangle is a quadrilateral, that's always true. A rhombus is a square. A rhombus is a square. Oops, too far. So a rhombus and a square. So notice to go from a rhombus and head down to a square, that would become more specific, right? We're heading down the family tree. So if we look at the down and our key below there, sometimes a rhombus is a square, sometimes it's not. So that is a sometimes. Next one, a square is a rectangle. Okay, that is being less specific, so that is always true. Oops. So my whole screen there. Hold on one second. Here we go. So that is always true. Okay, so what I would like you to do is pause the video, and I want you to finish sorting all of your statements. And then when you're ready, hit play again, and I'll have the answers for you. All right, so now you should have already sorted. So here we go. A rhombus is a parallelogram. That is always true because you're being less specific. A trapezoid is an isosceles trapezoid. Sometimes, right, sometimes it has that congruent part. A rectangle is a trapezoid. That is a never. A rectangle has to have 2 sets of parallel lines. A trapezoid has exactly 1. A parallelogram is a rhombus. Sometimes you can be more specific. Sometimes you can't. A kite is a parallelogram. That is a never. A kite has to have no parallel lines. A parallelogram has to have 2 sets of parallel lines. And then a square is a rectangle. That's being less specific. So that is an always. I do enough room. All right, so there are your answers. Oh, you know what? I goofed up. A square is a rectangle always. I put it twice. Oh, look at that. Okay. All right, so there's 2 of them. A square is a rectangle. I goofed up. Sorry. All right, so you're going to be doing an always, sometimes, never practice with some of these to help you just try to figure out, make sure you understand that family tree.